Alright, so let's go. Still can't show them.
We pull up first one here because I had to get more money with another. Here, message me. Say I got to say, okay? 5 minutes later, this one message me after we had a carry grab by. Yeah. That's what y'all already.
Alright. Alright, so let's take this small note here, right?
Why is we killing my grandpa?
Alright, so differential equations are generally of this form here. Right? Once you see dy dx, you have a differential equation. Based on the differential here, we'll be able to know the type, right? So we have two types that we're going to look at. Right? We're going to look at a first order. That's what we're focusing on today. If we move fast enough, you'll get to do second order as well. Right? So first order differential equations are generally of this form, right? It looks something like that. And B, second order, generally looks like this. Just watch here, please. If you look here, right? These are first order and second order differential equations, right? First order, second order. Watch this here. If I were on the other hand, right, to take dy dx and square it, right? This is still a first order, but is of second degree. Okay? Right? But generally, what you will be solving, first order, first degree, second order, first degree. That's okay? But there are also equations that could be second degree. All right? All ours are first degree, right? I wanted to just if you see that word, what it means, right? So we are going to focus on how to solve first order. Right? And as I said, we did it in unit 1, where we used what technique? Emily, what technique we used in unit 1? Online, anybody know what we use in unit 1? Anybody know online? Who online? Rihanna? Rihanna, Amanda, you remember what the first technique? The solve first order. Yeah. Anybody remember number 1? Anybody online? Amanda? Right, so to solve a first order, we can do number 1. We can do something called separation of variables. That's what you did in unit 1. Right? Or you could use the integrating factor. All right. So these are the two techniques that we're going to look at, right? A, separation of variables. B, integration factor. Should we put up the x, y, z? All right, so what is here, right? So if we have, right, if we have something like this here, guys, if we have dy dx is equal to f of x dot g of y, then in order for us to solve this, we can separate the variables, right? All that means is to bring in the y on one side, x on next side. Okay, so everything with x here, everything with y here. So we will end up with 1 over g of y dot dy, Emily, and bring the dx on this side. Right? So now we have everything here in terms of y, everything in terms of x. Then we integrate. Okay? And then when we integrate, we solve for y, right? Okay, so we can separate the variables and work it out. This is not that popular in Unit 2, but it came once or twice. But what you rarely see in first order is you have to use integration factor. Right? Once you can't separate the variables, this is what you're going to do. Most of your questions are this. Huh? Copy it down. Let's try one now. Huh? What was the item? Right. How are we doing this here? Well, yeah, technically, right? Technically cross multiply, right? But of course, we want to separate the variables. So you're bringing the cos y on this side with respect to y and bringing the dx on this side. Now we have left hand side in terms of y, right hand side in terms of x. What's the integral of cos y, Shibish? Huh? What's the integral of cos y? Huh? Sine? It would just be sine y. Right? I strike one, so you come in front here. Right? What's the integral of 3x? 3x squared over 2. Plus c, don't forget the plus c. And last part is what? Last part is to make y the subject, or you can leave it like this, right? But generally the y to make y the subject, right? So that's sine inverse 3x squared on 2 plus c. Right? Yeah, they include the plus c in there as well. Right. This here, you gotta remember the name of this solution. This is your general solution. What is the particular solution? Right. So they give you an X value and a Y value, and you have to solve for C. Right? That particular value for C is called a particular solution. Okay? What's the integral of 1 on X?
On X.
What's the integral of 1 on Y plus 1?
1 on Y plus
What's the integral of 1 on Y plus 1?
1.
Ln Y plus 1. It was Y squared. Right? So you have to remember how to integrate, right?
Yes.
Right, Nikolai. Come step. Yeah, come forth, Pikachu. Come step.
No,
talking to the
that's the doctor is asking.
What's the matter?
You know, I
We're done next one.
We want this weekend. Every weekend. I don't know, every weekend.
Right. Oh yeah, solve this fast. Yeah. Why not go down? Really big. Oh yeah, try that fast. Same thing, right? All the Y on one side, all the X on one side. Oh yeah. I done. Here, I done this. Alright, let's do it again. We are now again too. Right, so we want to be able to bring all the Y's on this side, right? And do just switch them earlier. Remember, we need to, I'm going to divide by y plus 1 here. I'm going to divide by x here. So you will get 1 over y plus 1. And you'll get 1 over x dx. Right? You can't just magically switch them around, right? Because how you can just put the y plus 1 here and
We just.
yeah, well, you gotta move it properly. Right? So you have to divide everything here by y plus 1, same thing here. Divide everything here by x, same thing here. Okay? Normal math rules apply, right? You can't just magically switch them around. Okay? Right? This will cancel here and you'll get 1 on x. And this will cancel and you'll get out. Okay? Then you integrate. What's the integral of this again? Ln y plus 1. What's the integral here again? Ln x plus some constant, right? Right, but how are we going to simplify this now?
Divide by ln.
Huh? Divide by ln.
Oh.
Oh,
Multiply by ln. And divide by plus or minus.
but if you are a little too much gas, huh?
Separate.
Separate ones. Huh? Separate one.
So you carry line next side. Y plus 1 minus 1 x.
Yeah, but remember the objective is to make y the subject of the formula. Break up what? How breaking up that? Have no rule for that. It's multiplication is addition. Try what? Right? So when you reach here, all you could do is carry across ln. What's the inverse of ln? Right. So you'll get E ln x plus C. That's okay? Right? And then yeah, just now I'll do that. Right? But we could break this up. There's an addition here. So this is E ln x multiplied by e to the power c. Right? What's E ln x?
1
X. So y plus 1 is equal to x. And here we can do, right? We can let e to the c be some constant a. Right? We can let e to the c be some constant a. So what we have here is x multiplied by b. And we'll be left with y is equal to ax minus 1. Right? Where a is e to the power c. Right? Get the point looking nicer? No, but that's the reason why, just to make it look nice. Right? No major reason why. You can leave it like here, e to the cx. Right? All right, so that's the way you work out questions that look like that, right? Oh, yeah. Copy that out. Right, so but here you always have to reach down here, right, Ranju? You always have to reach down to the point where you make y the subject of the formula, right? Right, so make sure you simplify properly. And for Nikolai and them who was right, saying that this I could break this up, right? That's not the rule, right? Right, so if it's a product, then you can break it up like this, right? Get the plus sign in between the lines, right? or if the minus sign in between the lines. That will again be because the variable thing.
Oh, so you really break too? Why the things?
Huh? I put it. No, I put it. I put it. Huh? Ready? Let's go again, right? Anybody writing online? Right, by the way, Nikolai, suppose, right, suppose what she is to get is that E there. What is good to get rid of the E? Like you have an equation with a value instead of E. What she is do?
To get rid of the.
Yeah. Well, sorry, not get rid of. You have value to replace the.
When you're something about you know, like that's that.
Huh? No, what you need to get is y for x and y. Right? Conditions.
So I'm trying to see.
That's again the particular solution, right? Right? So the one that I'm giving now is like that.
Basically, no.
Right? Try that there. So what you're going to end up with is not a general solution. What you're going to end up with a particular solution. Right? Take your time, do the same thing, and let's see if we can get a particular solution. Right? The particular solution will not have any letter, any constants, because you'll get a value, right? That is 2xy with now. Try that way.
Should be bigger than 86.
Right, take your time. Right, remember you have to get a particular solution, right? So Vanaya, where are you gonna move there? Vanaya, where are you gonna move there? But any x on the right side already? Why you move down? Remember you want to get all the x on one side. So the problem on the right side is the what? The y. So why you do with the y? Right? And then integrate, right? Do that tomorrow. Do that quickly there. You do online, you can just message what you get the constant, right? Right.
For a competition, something so. I go gas for another.
Am I done?
Yeah.
But then this is why this is unit one. I need to unit two part.
Yeah, well, I didn't say that.
No, but still, but it's. Huh? C is log, I'll check this now, not too sure. Are you another one again? Anybody else got? Yeah?
Yes. Just trying to see how.
Are you ready? Right, watch here. So step number one is to separate the variables, right? So in order to remove y, I'm going to divide both sides by y. So I'll get 1 on y and a kind of dx, right? 1 on y dy, I'm moving across dx, is 2x over 1 plus x squared dx.
Right.
Right? When you reach here now, you can integrate. Right? How do we integrate? 1 on y. The integral of 1 on y is ln y. I hope you all see how important it is to be able to integrate, right? In order to do this differential equations, right? What's the integral of 2x on 1 plus x squared? No. The differential of this is this, right? So it will be ln 1 plus x squared. That's okay? The differential of this is this. And of course, include your plus c. Right? When you're making y the subject, what to do? Carry it over, right? Carry over ln, right? So you'll get y is equal to e. The inverse of ln is e. Ln 1 plus x squared plus c. Huh? If you want for now, but let me simplify it a little further. So y is equal to e ln will cancel. You'll get 1 plus x squared, right? Multiplied by e to the power of c. That's okay? Addition means multiplied, right? And if you want here, you can solve for c, or like what I did a little while ago, I could let e equal to e to the c, right? Just to make it look nicer. So I'll get y is equal to a by 1 plus x squared. And they said when x is 0? When x is 0, y is 2. So I can plug it in here. 2 is equal to a by 1 plus 0. A is 2. Right? So the final answer looks like this. Y is equal to 2 by 1 plus x squared. Right? If you didn't do it like me, you would have had to solve for c. Right? So you would have gotten 2 to the c is equal to 2. So c is equal to ln 2. Right? So your answer might have been a little different to me, and you probably had ln 2 in front here. Huh? Both of them correct. Either one could do it. Right? It's based on how you write it. Okay? It's based on how you write it. That's okay? So your answer would look like this then. So y is equal to, instead of writing e, you're writing e to the power of ln 2 by 1 plus x squared. Right? Done? So what e ln 2? 2. Same thing, right? That's okay. So you can use either method you want. I just leave it like that one time. You okay with that? All right, but this is where just to warm you up because this is unit 1. Now we're going to the unit 2 stuff.
Going fast, It's like I was being class and I tell everyone it's so and like yeah, it's like I just stop going class.
So why is it so fast?
Oh, you see, you can spectrum now. Like you can spectrum. Yeah, exactly. Yeah, yes, you can everybody should but then now like I got it.
Are you okay with that?
So what time do we have? Yeah, I want.
When I get, you know,
That's a serious thing.
I get one that right up and I want to like this. You want in our room. Alright, so let's start integrated fact. Alright, so if you look here, right? Well, let me write this now, right? Right, in the notes I sent, I use a different symbol. I didn't use I use mu I think. Right, I use mu, the same principle, right? So these are the ones that you really going and see in your exam, right? So if you were to get an equation looking like this, I mean, you're right there. Oh, right, what you say? So sometimes you'll get a differential equation looking like this. Right, you'll see the problem there. Can we separate the variables there, Andrew? What? Can we separate the variables there? No, it's kind of hard. It's kind of hard to get y alone on one side and x alone on the next side, right? So whenever it looks like this, we have to use a new technique called the integrating factor denial. Oh, actually, going back on Saturday, you'll get an exam next month. Right? All right, so once you see an integrating factor looking like that, once you get a differential equation looking like that, we have to use a technique called integrating factor. Right? So here's the general solution. The general solution for a differential equation that looks like the one on top is y by I is equal to the integral of I f of x, where I is written like that. I is equal to e to the integral of x log dx. Right? And then you would recognize that once you work out I properly, this integral here really easy to work out. All right? So let's make a note. It might make sense out here, but copy it down, and I want to copy down. Copy down everything in red and black.
Basically everything.
Yeah. Right? And I'm going to give you an example to show you how it works. But integrating factor is basically used when you can write a differential equation in that form. Right? Have a little thing in red there. You're seeing that the coefficients of dy dx is 1. You're right, you're done. I know you do it, sorry. You know what I'm doing. Write it down. Huh? Right, so write down the equation, and I want to show you how to use the integrating factor. Show you 2 examples, and then you'll go back in TikTok and see if it makes any sense. And the video I send you on TikTok. You see, that's what it is. That's what it is.
Sure?
Yeah. But if follow went on, I didn't watch it on its own. Alright, so you're gonna watch it back up and see if it makes sense.
So here is now, really, what time again?
What time again, bro?
Yeah, half 6. I was still. We just not paying these extra loud.
I don't know, I guess take it on computer.
Yeah.
What's number 4? Huh? Wow. I've already back at the end of the video, it's about everybody.
Oh, me?
Yeah.
Yeah, what do you do with video? Don't say you can scroll with video.
Yeah, we don't worry. But that challenge too, right there, you get it, bring it back next month. You're not saying, I think I'll get the next one. Was it was too loud, it was too loud, too fast. So why you can't lower it? Or like background and play that lower. No, the point I was not to explain it, for you to.
One of them, yeah, equation readers.
Yes.
And you have that like one of them, so I was like, oh, boy. And that's why I was doing one meeting when I should go.
We got you. And I.
Right, simple, same thing. Right, the purpose of it is to get a nice and easy, integral. Huh? A TR? One eye?
It was right. It's a good way, but one eye is a mistake.
Right, so this integral here is supposed to be easy, right? Alright, let's go, right? So let's try an example here. Why am I- All right, we can do this thing because I'll show. Right, I'll show you all together to do this. Just write that down, please. Integral of tan. Integral of tan is ln seconds. Right, just write that down. The integral of tan x is ln sec x or minus ln cos x. Write it down, please, Arya. No, write it down, please.
Yeah. Still up to date. Still up to date. You got the last one. Yeah, I think he's gonna make it again. But how much now?
Yeah, that's not. All right, number one. All right, so what is here, right? What is here on? Right, so if you look at this one here, can you separate the variables here? No, and there is no y, right? Oh wait, make a mistake here. Right? Right, so now we cannot separate any variables here. So here, we're going to use integrating factor, right? So the integrating factor, this is the general rule. And I'm going to show you where it comes from in a little while, right? But the general rule is I could take y, multiply it by the integrating factor, and that will be the integral of I by whatever I have on the right-hand side here, 2 sine x. Right? So the general solution, sorry, I get 2 there right? Right? Huh? I'll show you that now. Right? So once you have dy dx, the coefficient is 1 and it's in this form, this is the general solution where I is equal to e by the integral of whatever next to the y, which is tan x. That's okay? Right? So generally, if you look back at the note, it's of the form dy dx plus yp equals to q. So I is always the integral of p. That's okay? I some notes, right? So what's the integral of tan, Divish? What's the integral of tan? I just make it write it down. Wait, so how do you pronounce his name then? I'll pronounce your name. Well, this one do answer at all. All right. The next Divish, right? What's the integral of tan again? The integral is minus ln cos x or sin x, right? I mean, sec x, right? So I'm using the sec x version for now. I'm using the sec x version for now, right? You okay with this? So this is the I, Arian. So Arian, what's E ln sec x? Yeah, I know it's I, but when it's simplified, the same. Right? The E and ln will cancel and you will get sec x. So I is sec x. That's okay? Yeah. Right? So Emily, what do I do now? Now I know I, right? What to do now? No, not here. Not in this case. So here, I'm going to plug it in here, Emily. Right? So I'm going to plug sec x in there. Right? So I'm going on, I'm going to label it so you know what happened, right? So I'm going to substitute I in equation 1. So I'll get y by sec x is equal to 2 by the integral of sec x dot sin x dot dx. Right? So this left-hand side will not change. What's the integral of that? Huh? Nice. Because sec is what? Sec is 1 on cos. So it's like saying what? Tan. And the integral of tan is ln sec x. You okay with that? Right? You know what? Back in the do that. Right? And then you want to make it look a little bit nicer. Yeah? So what we could do? So we can divide everything by sec if you want. Right? So we could divide everything by sec x. Divide everything by sec x and you'll get y is equal to 2 ln sec x plus c, sorry. Huh? Oh, yeah. Oh, yeah. Yeah, 1 year short. Right. One is actually now. Yeah. One again, 20 laps and wells. That's good. The man better 20 up. One extra view. All okay with that? Let's go again.
Yes. Well, that's right. If you like the world, because he can't get English.
Online, any questions? Right, so just to give you an idea, 10 marks and 4 marks to this, right? 20 marks. Right, so let's zoom in a little bit. Try that, please. Online, any questions, Mariah? Samira, all okay? Ariane? Are you okay online there? Alright. Try this one, please. Right, those who are writing exams with our school, right? Remember to fill out the form, right? Mariah? Actually, you guys will. Shivara. I'll be sure that's what. Tamia, make sure you fill out that form, right? Yeah, it should look like that. Huh? Yeah, plus differential, DYDX. Take your time, follow the steps, right? Aaron, do you think the boy? Aaron, you can't tell what you're. Oh, yeah, yeah. I did not, I did not put it in. Take your time, right? So you have to shoot up, yeah? And then do the last part. Why primary divided? Why primary divided?
So there. Can.
Timothy, you done? Sean. What question, boy? Should we, what's the first step? And I is what? This kid, I is what? And you got out, why no? Huh? Equally and you got out what? It's 10 marks over there, by the way. So pay no test. So we're right, it's 10 marks. That's why you realize sometimes that it's good to go and do the questions that they can get the marks on and go back and try to do them. Huh? Right. What's the integral 10x again? What's the integral 10x again? Shows up in the mind because it's women.
Yes, but I'm still.
That should have no worry. If it went 4 zeros in a row. So because
That went into give me.
2 zeros. Huh?
We can help you guys. We can help you guys.
Well, so why it was on the board?
Because was the first level kind of. You didn't nobody gives up. Yeah, was that? Will you accept it?
Alright, so I just check in to make sure you have the right thing. You recognize that I is equal to e to the power of the integral of tan x. And as ln, e ln will give you 7. General format I by y is equal to I by a right hand side. In this case, okay. The last one was fine. Look at that. Iy is equal to the integral of x squared. Yeah. Yeah. So Iy is equal to the integral of. Right? It's supposed to look like this earlier. Right? You can take off I made a mistake and left I there, right? So that's put second. Right? But because there is no sec x there, my advice here is to write it as 1 on top. Yeah, kind of. Kind of. We get it? It must be in that form, right? Sine plus C plus X. Taking off that, right? Right, let's go through it. Right, let's do all this one. I'll give you a 10-minute break and then we start some harder ones, right? Are you ready? Right, so step number one is that you have to identify that this is of the form, right? dy dx plus yp is equal to q. Right? It's of the form because the coefficient here is 1. Right? If the coefficient here wasn't 1, what you'll do? You will divide throughout. Nice. So it means that your general solution is I by y is equal to the integral of I by q. Q is this. So I write in seconds. Right? Where I is equal to e to the integral of tan x. Right? The integral of tan x is ln sec x. Right? The e and ln will cancel, so you'll get sec x. Remember, sec is 1 on cos, right? So you don't have to write it like that. Right? When you reach here now, you're going to substitute, and you will get I by y, which is 1 on cos x by y, is equal to the integral of I, which is 1 on cos, by I can leave this one like that because it's sec by sec, right? This is y on cos x is equal to the integral of sec by sec, which is sec squared x dot dx. That's okay? And the integral of sec squared is? The integral of sec squared is tan, right? So you'll get tan x plus c. And the answer in terms of c, what letter do you use? C or A? See? What do I do now to make it look like the answer? Right? Multiply everything by what? Multiply everything by cos x. So you'll get y is equal to cos x tan x plus cos x by c. What is cos x tan x? Cos will cancel and you will get sin x plus c cos x. You'll got till here? Yeah. Oh yeah, just remember, yeah, that is. There we go. And everybody writes it, go like. Well, let's see. After write it up, it must be there. I think I will stop there. Because we're from second. Hello, okay, what happened? And the last part is what? What's the last part? The last part is that we have to substitute to get the particular solution, right? Substitute y is 2 on root 2 and x is pi on 4. Put it in here and you'll get 2 root 2 is equal to sine pi on 4 plus c cos pi on 4. Right? If I'm not mistaken, sine pi on 4 is what? Root 2 on 2, right? Plus c by root 2 on 2. Right? Do your little thing, minus out, and away again. Huh? 2 root 2 plus 2 root 2 is 1 root 2. Gonna be 1. Yes? This minus is divided by this. And solve for c. One. For real?
Yes, sir. Yes, sir. Yes, sir.
Oh, right. 202 is root 2. Yeah, so C is 1. So your final answer is y is equal to sine x plus cos x. Right? That is called a particular solution, right? So next we got some harder ones like this, right? Right, wait, before you go, and take a little break. Watch this here. Right. Where did this come from? Right, this general solution, watch this here, right? If I were to multiply every single term here by, if I were to multiply every single term by I, watch what will happen, right? I will end up with cos x, sec, right? I'll end up with sec x dy dx plus y tan x sec x is equal to sec squared x, right? If you look closely here, you might recognize that this, I could rub up this line, right? You might recognize that this left-hand side here product rule, where the product is y by sec x, right? If you differentiate this, you'll get this. If you differentiate this, you'll get this, right? So that left-hand side is really product rule. So if I were to differentiate this, and I'll get that, right, is equal to sec squared. So it means that a solution for this is really y sec x, carry across the differential, and I'll get the integral. Right? This is really y by I is equal to the integral of I by sec x. Right? So instead of doing all of this, we just jump to the general solution. Okay? So we don't have to do this anymore. We just jump in straight to this. All right? Watch the TikTok video now. Watch the video and see if it make real right here. Watch it right here for the move. Make sense? Watch the video and make sure it makes sense. Right? And when it's finished, I'm giving you here on 10 minutes. In 10 minutes. I don't like watching video and see this thing in the example. Right? Somebody watch the video now, please. I can make it sense. It doesn't really say, no. I spent 2 hours behind that video.
2 hours? Well, 1 minute video.
Huh? It was like 10 seconds. Yeah, hold it. Go outside. Or you can sit down there for 10 minutes. And my sit guy, Chewy move down. Outside. Alright, so online 10 minutes, right? Who I can trust online is. Some of you can watch the video come up this and tell me if it makes sense, right?
Alright, next thing we do is order. As walking up, it's just driving with them. Yeah, man, it's not your running up. He's sitting out.
And like, I always some general was the house where I yesterday, Saturday, yeah.
Rice, real shit to be order.
Before I'm going to-
But what I got, what I want, you want to tell me that, like I say, yeah, still in the village before. Say, I know we just ordered tofu and just okay.
Let's start, sorry, let me start back here. Right, the problem with this one is what? I have a slight problem with this one, but you get.
Actually,
What's the problem with this one? What you get? It's a little bit different to the last one. So I just. What do you say? Right, so the problem is quit back in the opposite. Right. What's the problem here? Look at it. It's not looking like the last one.
Hey, this thing, check this out, because this thing, you're gonna know.
Right. Yeah, so we have a slight problem here. It's not looking like the last one. Remember, it must be in this form, right? It must be in the form dy dx plus py is equal to q. Right? How do I make it look? How do I make it get in that form? Right. Divide everything by 1 plus x squared. It will cancel and then you can go ahead and follow the same steps. Okay, so divide everything by 1 plus x squared. And start the death now. Right, take your time, divide everything by 1 plus x squared, and then same steps afterwards, yeah. Take a time with the integral, it's a very simple integral, don't overthink it. When we did integrating fractions, remember the two options, right? You're done? TV, shall done? That's the cube root of x there. So when y is 2x is 0, right? Right. Put it in the divided. Right, so what I did. I did what, when it's y, so factor only y. Right, so as I said, the problem with this one is that the coefficients of dy dx is not 1. So I'm going to divide everything by 1 plus x squared. So I'll get dy dx plus 2x over 1 plus x squared by y. Right, so I just pull out the y one time by the cube root of x all over 1 plus x squared. Right, follow through all the steps. But you're not wrong. Right? So your general solution is what? Right? Y by I is equal to the integral of I by the cube root of x over 1 plus x squared, where I is equal to e to the integral of x plus x, right? What's the integral of 2x over 1 plus x squared? Right? Remember, when we did partial fractions, you had 4 things to look at. Normal integration, ln, double traits, inverse traits, and then substitution. Yeah, substitution. Right? So here, if you're not seeing it, use substitution and see. Right? But look how simple this is. What's the differential of this? 2x. So we know is e ln. Yeah. Right? But even if you don't see it, substitution is good. E and ln will cancel, so you'll get I to be equal to 1 plus x squared. Okay, put it out. Wow. Are we done? Can you get up? Right? So when we substitute, what we'll get? We have I, right? Good. So we'll get y multiplied by 1 plus x squared is equal to the integral of 1 plus x squared by the cube root of x over 1 plus x squared. This will cancel. And you'll get y by 1 plus x squared is equal to the integral of x to the 1/3. Right? Remember, cube root means x to the 1/3, right? No. Cube root is x to the 1, 2. What's that? No, cube root means that's it. Right? So that'll be add 1 to the power, you'll get 4 and 3, divide by that new power. Right? Plus c, right? So you'll get y by 1 plus x squared is equal to 3/4. This here is the cube root of 3 by x to the power of 4 plus c. Okay? And then you can divide everything by 1 on x squared. And not looking too nice, but and that one more part, put it inside, right? Remember 4 and 3 means x to the 4th by 1, 2. Huh? Huh? That was it, what's our next part? Was that it? Huh? Oh, for what? When x is? X is? Y is? 2. Right, x is 0, y is 2, so this will be 0. This will be 1. So again, y is 2. C is 2. Anybody get up? When I put 0 here, this becomes 0. When I put 0, this is 1. Check and see now. So therefore, your particular solution looks like this.
And it says some y is 1. It's a y, that is 1.
Or find y1. Right, and the last part is y bracket 1. But Ariane, must sit down here now. Open up, boy. Right, when y is 1, right, when this here means when x is 1, the y value. So put 1 in here, you will get what? When you put 1 in here, you'll get 1, you'll get 2, you'll get 3/8 plus 2/2. Anybody got 11 on it? Online? Anybody got up? Check it back and make sure now that you got C is 2 and y is 11. When y is 1, you get 11 on it. Where do you understand, Ariane? Rihanna. Which part do you understand? From point 1, 2, 3, 4, or all? Right. Let me start back here. You understand this? That's the question, right? Yeah. So just stop me, right? If you don't understand, just say no. Right? The problem with this is that I can't use integrating factor here because it's not of the form dy dx plus py plus equal to q. So I'm gonna divide everything by 1 plus x squared. Right? So I'll now have 1 dy dx py equal to q. You okay with that? Right? This here going to help me find my I is e to the integral of this. The integral of this, differentiate the denominator, and you'll get a numerator. So the integral of this is ln 1 plus x squared. E of ln is 1 plus x squared. You okay with that? And I'm multiplying I using the general solution. Y by I and I by this. Right? You'll recognize that the 1 plus x squared cancel off, and you get this here. The integral of 1/3 is x to the 4 and 3 over 4 and 3. I flip the 4 and 3 over, and I wrote x to the 4 and 3 at x to the 4th by 1/3. And I got this. Right? Cube root of x to the 4th. Right? You okay up to here? Are you come and sit down here now? Right? So when I reach here now, I'm trying to make y the subject of the formula. So I'm going to divide everything by 1 plus x squared, 1 plus x squared. So I get this, and I get this. When you reach here, that's the general solution. Right? That's the general solution. You okay with general solution? Right. And I plug in x is 0, y is 2. And when I work this out, I got c is 2. Anybody else got this? Actually work it out?
Yeah.
And then just copy down my thing, right? Right.
Oh, if X is 0, so what is?
Right. And then when you reach here now, the question asks for y brackets 1, close brackets. All that simply means is what's the value of y when x is 1. Right? So I put x is 1 here, and x is 1 here, and I got this. You okay with it now? Okay. All right, let's go again. Let's see this one, right? Yeah, that's right. Next one. So, assuming today, forget the y is one part, right? So that therefore. Pay attention, I'm not telling you which technique to use, you do your thing, right? Oh yeah. Try this one here, please. In the back, you're talking. All right. Come in the back there. Right. You have to figure out which technique to use. Is it integrating factor or the separation of variables, right? Look at the answer. This one. Yeah, it's kind of look like that. In the end, the answer have to look like that, right? Huh? Good. So you have to figure out if it's separation. Right? Separating variables or integrating factors.
I feel like something wrong with it, like it. I agree with that. Because it's something wrong with it.
Right? How you know if you can get all the y on one side, all the x on one side, separation of variables. If you can't, you have to write it in the form dy dx plus py q. Yeah. What? If right.
If it's not on that form, right?
Yeah.
That question can be enough.
So that means you have to use
Regular.
regular, that is what separating variables, right? So you're probably at yes, separating variables, that might be. Right, so remember you're trying to, so don't focus on this too much as yet. Separate your variables and work out on them. Emily, are you done, Emily?
That we want to walk to life.
One more before. She's talking. Huh? You can do substitution. Definition. Check and see the difference of the numerator, denominator, the numerator. So you can not with fraction.
Yeah, you could, you know, like, you know, say. Yeah,
Might be a plan.
yeah.
Very true, was it? And then they are really-
Right now, have to watch out, take the video.
Too much, 2 seconds.
I watched it 3 times.
Are you getting ready?
Yeah, again.
Anybody guys online? If you guys just message QED, right? We're gonna start with us now. We're gonna start with us now, right? No, just really take all the time. I just giving you one line. That's one line. Actually, I'll make it easier.
So what I'm guessing.
Get up. Go ahead, do your thing. You want to go wait again. Yeah, I think that's a lot. That's one down. We can apply somewhere. Make easy where you like see.
Você bloca o outro atender, o S is igual a logo.
No, you have E, C is E to the C.
Oh, with the AI, see.
Big C that's constant. Big C is R and you read that.
Yeah, we get. Oh. Oh, I know. That's.
Because of the R. Alright, let's see what you got. And then let's say when y of 1 is 1, solve it, right? Right? All they mean is just find for C, right? All they mean is just solve for C. Alright, let's see if Rihanna got this one. Right, Rihanna, so you should have here, and you integrate here, and you integrate here. The integral of 1y is ln y. The integral of 2/3 of this is 2/3 ln of the denominator plus c. I don't want, if I bring it across, I can't cancel. So somebody did this, right? You can't cancel e ln here, right? This is e of 2/3 ln. The 2/3 has to be here. And then you could say e of ln will cancel, right? Right, so I'll put the 2/3 there. Now I want to make y the subject. That'll be e of ln x squared plus x to the power of 2/3 plus c. E of ln will cut. All right, let me just write out that step. You'll get e ln x squared plus x to the 2/3 multiplied because of the plus e to the power of c. Right, e of ln of this will cancel. So e of ln of this is this, right? I shouldn't say the cancel, but you know what I mean, right? X squared plus x to the 2/3. E of c, let's call that a big constant c, right? What letter they use? C. So I shall use that k then, right? Where big C is e to the power of k. Nice. So y is equal to big C. This is the cube root. So I'm going to find the cube root of this plus this all squared. That's it? Yeah. That's the answer. Right. That's it there, so you prove it. Right? Then they said solve y1 equal to 1. What does this mean, Eden? What does this mean? Right. So it means that when x is 1, y is 1, right? So plug it in there, you'll get 1 is equal to c by the cube root of 1 squared plus 1 all squared. So what is that? So that's what? 2, 4, cube root of 4. Okay, can I give you something nice? So c is equal to 1 over the cube root of 4. Right, so I guess I'll leave it like that. 1 over the cube root of 4 by the cube root of x squared plus x all squared. If you want to make it look a little bit nicer, right, we can bring the two cube roots together. So you'll get the cube root of x squared plus x all squared all over 4. Right, these two mean the same thing, right? So you can make it look like that. Pull the cube root over the whole thing. Yeah. And your third line where? Oh, I mean like, I don't want. It won't change anything, it'll still be a constant. No, it's still a constant. Sorry, come on. Like when you do normal integration, it's your parentheses, don't mind. When you work it out, in the end you get the same. One more. One get it fast. I can get it fast. This one, Right, anybody writing online? Let's try one more. Let's try 2018. I'll give it 2019. Go.
Yeah, 2 weeks in a row.
Kaya class again. Class Friday.
Ah, yeah. We have last Friday. What Friday?
I don't come there, no.
Last one. And then I will show you the intro to second order.
So it's different.
Right.
Yeah, you just have one top of one. Yeah, have two.
Right. In part A.
Right, like you
This one not so bad. Right, so as soon as you see part A, how you do that? How you doing A part 1? Timothy, how you doing A part 1? Separation of variables, or I was zooming there for you. Separation of variables, or okay, or second way. How you do that? Because they can't separate X and Y. Right? Because you can't separate X and Y, that's why. All right, oh yes. Don't worry, part 2 gets in part 1 alone. Take the equation and show the answer in that. I might need to remember some figure rules, right? So everything in the movie, you have to look up. Oh yeah, look at those series. Your business. Your business. Or it's time 2x again. But it's time 2x.
I don't know. I already know. That get one thing already. The change is like it was very yeah, but like you practice it, yeah, they say
I have last one order and then I want to show you introduce second order. Huh? You don't know how to do it. You what? Just put it in the form. DYDX plus. What you doing? You put this here earlier. Right, carry it across and then what? And then divide by cross x. Carry it across and divide by cross. Remember this is y prime, huh? Y prime is dy dx, right? Yeah, that you what? Minus whatever they get. So the check it and see. Yes. What's the integral tan? 4. What's the integral tan? Ln sec x 4 or minus ln cos x. They probably use that one, right? Minus ln cos x. That's the same as you know it's before this one.
I was rushing home. It wasn't very constant.
Just rush again in the mix. Online is again, that's QED. So we share it still. Yeah. Yeah, sure. Done, Benaya. Let me do this one now. Right, I know pass through, right? This is this is 2018, right? Right, so what's the first step, Benaya? What to do? It must be in this form, right? The objective is to get it in this form. Right, so as the y term on the left side. So I carry it across, right? I write in dy dx instead, right? Minus sine x by y is sine 2x. What do I do with the plus? Right, because I want to get 1, right? So I divide in everything by cos x. So I'll get dy dx minus cos over sine tan is equal to sine 2x over cos x. Right? What's the integrating factor here, Shavish? Minus tan x, right? Right, because of the minus sign. What's the integral of minus tan x? Ln, no, ln cos x, right? Because it's a minus here. So if minus and minus are plus, and you'll get ln cos x. E of ln is cos x, right?
Yeah.
Yeah. Explain backward.
Explain.
This part? The integral of tan is ln minus ln. Right? And the minus will cancel. Huh? This part? E of ln is cos. Then cos x. The integral of tan. And what's the next one? You write it down, right?
If you use any formula,
What's that?
use any formula, if you use any formula, and prime of x by f of x is equal to f of x 3 and plus 1.
Yeah. If you see it, you can use it. Right? So I cos x is equal to what? Is equal to the integral of sine 2x over cos x multiplied by cos x. Right? Of course, you will see what happened here. Cos x cancel, right? That's okay. And then we want to get sine 2x. So now we have y dot cos x is equal to the integral of sine 2x dx. How you integrate sine 2x? Huh? Minus cos 2x. Huh?
Like all of it is like a half. Minus a half plus cos.
Minus a half cos 2x. Oh yeah, or something better. Right? Oh no, I hear something else the first time. Right? So the integral of sine is 1 over the differential of 2x, which is 2. The integral of sine is minus cos 2x. That's okay? But this will not give you the answer in Finaya. Sorry, I mean, Emily. You won't get the answer, but you'll get the answer. Okay. So there's something else that we need to do to get Ugosha Rabbit off. Sorry? No, I just write it in case. Oh, shucks. They must say should have know this. No, I just write it just in case they need it. But we might need it here. Because this is not the answer. Right? The form that they want it in is 1/2 sec x minus plus x. So what to do? Anybody? What to do? Right. Cos 2x is what? 2 cos squared x minus 1.
Yes.
Remember that? 2 cos squared x minus 1.
Sine squared minus cos squared.
Now we're going to do using this one.
Oh.
right? So that'll be minus a half by 2 cos squared x minus 1 plus c. So I'll make a substitution for this here. That's okay? That's now. So when you work this out here, y is cos x minus a half by 2, that'll give you a minus 1, minus and a minus a plus c. Divide everything by cos, and you'll get y is equal to minus cos x plus a half, well, 1 over 2 cos x plus c cos x. Right? This will be y is minus cos x. 1 on cos x is 1 on cos x is sec x, so there's a half sec x. This here is c sec x. Right? If you look back at what they asked, I think that's exactly what they asked. Yeah, what's up? 2 cos x sin x, then yeah. Then right. Then you're gonna have to replace what sine squared is.
Yes, sine squared.
Yeah.
But when you do sine squared, you have got a square minus 1.
Right, but then your signs will be a little different. So it should work out. It should work out. Right, so you recognize besides integration, you get to know all the identities as well, right? All right, now I'm tired, right? Let's just take a look at how to do second order, and then you know, you got it right in though. Just look at it. Because I will start from there next. I already was right 20 time anyway. And I see you right more than normal.
Because I fall asleep during the class,
Integrated. I know, sir.
so I'm on the computer. See, people start getting our weekends.
I know, I'm fine.
And you'll be getting them.
Yes, and we put it back in. They can pick it up.
Online, for those who are awake, are you okay? Samira, Amanda, are you okay there? Ariane, nice. All right. So how do we solve second order? You don't have to write, just listen, right? And this is what we do next day, right? I'll send any notes so you can write over this stuff, right? Right. So second order looks like that there. That up there, that's like, all right, take a break and watch on the phone. One other finish. Yeah, every 4 seconds. 4, 5. 5. I'm finishing, that's not all we go through. All right, this is last thing. I'm gonna stop with you, right? In order for you to solve a second order is when you have a second fraction, right? You have 2 parts in the solution. A complementary function and a particular integral, right? Particular integral is only used when f of x is a value. Let's pretend f of x is 0. What we have to solve here, right? Pretend f of x is 0, right? We ignoring when f of x is a value. All we have to do is to solve this. That part of the solution is called a complementary function. And it really is. Right? Yeah, basically, it's a quadratic. Right? So what you do is you take the left hand side and convert it into a quadratic, which we call an auxiliary, and you solve it. If you solve a quadratic, you either have two solutions, one solution or no real solution, imaginary, but you all know what is imaginary. So you have three options. So
Complex numbers.
whenever you solve the left side, you have three options, right? And the three options will show. Right? The three options look like that. Whenever you have two solutions, one solution and none. Alright, so that's all I want to understand, right? And I'll give you the notes, right? I think I'm missing the actual part there. Yeah, I'm missing that page. Right, but basically we're gonna learn to solve second order and in two parts, like when it equals to 0 and when it's not equal to 0. So in order to solve it, we have to get a complementary in a particular
Private classes are normal time, right?
normal time.